Today we're going to start Unit 5. We're going to add some more derivatives. There's derivatives of logs, e to the x, a to the x, and ln of x to our list of already known derivatives. But first what we're going to take a look at from pre-cal and even Math 3, we're going to look at logs and the properties of logs because we are going to have to use this in class today. All right, so remember how we expand. Anytime we have the product rule, what went with multiplication? Addition. So we would break it apart like this. All right, quotient rule. All right, quotient rule, what goes with division? Subtraction. Remember here, order actually matters. Addition, it doesn't necessarily matter which one comes first and which one comes second. And then the last one, the power rule. That's when we take this C and put it out in front of the log. All right, so let's practice some of these with this. If you think you know how to go ahead and do these, go ahead, pause the video, and then come back to the video once you're finished. Okay, for this, remember, we need to change this to rational exponents. So x to the 1/4 over y to the 1/4. All right, and then remember here's division. So what goes with division? Subtraction, good. And then I noticed, wait a minute, I have powers here. The powers can go out in front. All right, now this one's natural log. It still has the same properties. So here I noticed it's dividing. So ln, and make sure you put the 2x plus 3 in parentheses, as well as, and again, this is minus, not adding like I just put it 2x plus 3 and x minus 1 in parentheses. Now I can't break up addition and subtraction, so they just have to stay like this. All right, now when I look at number 3, I see a minus and a plus. I can't do anything here. The only thing I can do is I can bring that 7 out in front. And then I have to just leave it like that. And then lastly, this one, to expand it, notice these are all multiplied. So I'm going to break them all apart using addition. And then I recognize the power property. All right, so here I can do the power property. So ln of 3 plus 2 ln of x plus 4 ln of y. So we're going to use this expansion later on in the lesson. So just remember this right here from pre-cal. Now, I want you to write these derivatives down. All right, you need to have them memorized. The derivative of ln of x is 1 over x, then times the, and if it's just not x here, say if it's like 2x, it's going to be times the derivative of 2x, which would be 2. All right, the derivative of e to the x is e to the x, and then whatever the derivative of that exponent is. Here, log base a of x, a is a constant, just remember that. Okay, its derivative is 1 over x ln a times the derivative of whatever's sitting here beside the log. And a to the x. A to the x ln a, and then times the derivative of whatever that x is. Now, I will say these are a little harder to memorize because we don't use these as often, but as we go through today, keep referring back to them when we come across it, because all we're going to do is find the derivatives of these. As you do your homework, keep working on them. That's how you're going to memorize it. If you're not doing homework, if you're not doing extra work on the side, then you're not going to have it memorized, and it is going to be a little more difficult later on down the road. All right, so here we go. F of x. So we're going to find the derivative here. And remember, work it just like you're going to see the chain rule here. Work your way from the outside in. Okay, I have ln of this right here. So I do 1 over, so f prime of x equals 1 over x cubed. And then I have to times it by the derivative of x cubed, which is 3x squared. So when I go to clean it up, I get 3 over x. All right, moving right along. And anytime you want to freeze these, feel free. I would say freeze it, you attempt it, and then see if you can get it correct. Okay, so all I have is ln, so f prime of x equals 1 over cosine of x, and then times the derivative of cosine of x, which is negative sine x. Now, be careful here. This is sine over cosine, okay? You still have a negative, so this is actually tan x. So be able to simplify it down all the way there. Okay? Here we go. Now I've got e to the 3x. The derivative of just e itself is e to the x. Okay, you basically rewrite that, and then you times it by the derivative of that exponent. So here it's going to be 3e to the 3x. All right, so this, I've got e again. Okay, so the derivative is I keep e to the tan x, and remember e is actually a constant, by the way, okay, and then times the derivative of tan is secant squared x. Now you can leave it looking like this, or if you want to put the secant squared x out in front times e to the tan x, however you want to write it. Now here f prime of x is going to be e to the x squared times the derivative of x squared is 2x. So if I go to clean it up, 2x e to the x squared. All right, so there's e. Now let's look at the logs. Log base 10 of x. Now remember, anytime you just have log and it doesn't have a base there, remember the base is 10. Okay, so if you just have log and there's no base there, it's 10. All right, so here we go. When I'm doing this one, I say 1 over x, whatever's sitting right here, okay, and then it's ln of a, that a value is 10, times the derivative of x. Well, the derivative of x is just 1, so here is my answer right here. All right, so let's do these. Okay, so f prime of x equals, it's going to be 1 over whatever's right here beside log. I have to put that in parentheses. And then ln of that base times the derivative of what's in there. So that's 2x plus 1. All right, so here, really, this is 2x plus 1 over x squared plus x, and then ln of 5 down low. All right, there's no cleaning up on that one. Okay, f prime of x. Now, if we go do this one, it's 1 over x ln of e. Now, do you recognize anything? What is the ln of e? It's just 1, so that's 1 over x. Now, some of you may have recognized here that log base e is ln x. All right, and what's the derivative of ln x? Just 1 over x. All right, so you could do that either way, but realize log base e is just natural log. All right, and also the natural log of e is 1. Okay, moving right along. Again, if you want to freeze this and do this on your own, feel free to. Now, I'm changing it up a little bit, and this is the one, if you need to think about it, the derivative of a to the x equals a to the x ln of a, and then x prime. Okay, a is a constant. Okay, and so all of these in 9 through 11, I have a constant, and even pi is a constant. Okay, so we're going to use this formula right here. This is something different. Okay, so here we go. It's going to be, you basically do f prime of x equals 3 to the x. And then we do ln of a, that's the ln of whatever that base is, so ln of 3. And then we take the derivative of x, which is 1. Okay, so let's do this again. We do 8 to the 4x to the 5th. All right, and then it's ln of 8. And then I multiply it by the derivative of that right there, which is 20x to the 4th. So when I go clean it up, And really, to be honest, you can just leave your answer like here. You're not going to multiply this 20 times the 8 because this 8 is raised to the 4 times x to the 5th. So you can just leave your answer exactly like this and you're done. Okay, so this one, f prime of x equals, you're going to say pi to the sine of x, then ln of pi, okay, and then we say times the derivative of sine of x, which is cosine x. Okay, make sure you know that this cosine x is not beside that natural log with that pi. All right, now number 12 is different, okay? I see it's ln, okay? So remember what the derivative is for ln. It's basically 1 over that right there, okay, times its derivative. Now, are you really going to want to do the quotient rule here? No, that's really messy. This is where the expansion of logs comes into play. If you ever see something that can be expanded, all right, ln of 2x minus the ln of x plus 3. Isn't it easier to take the derivative here and say 1 over 2x times 2 minus 1 over x plus 3. Okay, and then when I go clean it up, f prime of x equals 1 over x minus 1 over x plus 3. Now, you can simplify this further. Say if this was multiple choice, they may put a common denominator. So just be very careful on that. If they did a common denominator, you would have x plus 3, all right, minus x, because really what all I did was this needs an x plus 3, and this needs an x. All right, and then when I go clean it up, it's 3 over x, x plus 3. So be able to do that as well, especially if it's some multiple choice that's on the AP test. All right, moving right along. I see another ln, however, this is going to be really complicated because it's going to be 1 over that, something about quotient rule, chain rule. All right, so what we can do is expand this. So let's think about how we expand it. ln, first off, I'm going to say x minus 1 to the 1/3, and then x plus 1 to the 1/3. All right, this is the same thing as ln of x minus 1 to the 1/3 minus ln x plus 1 to the 1/3. And then I can use the power rule. Forgot my ln right there. Whoops, actually it goes right here. Sorry. All right, so here we go. This is just a constant out in front that's going to get multiplied. So y prime is, it's going to be 1/3 times the derivative, or 1 over x minus 1. And then derivative of the inside is just 1 minus 1/3. Okay, derivative of x plus 1, or ln of x plus 1 is 1 over x plus 1. All right, so y prime is 1 over 3 x minus 1 minus 1 over 3 x plus 1. And again, you can leave the answer like this. Just make sure that if you need to, you can get a common denominator and combine those together as one rational expression. All right, now this one right here, the derivative. Okay, well I've got, this isn't, we don't have to expand, it's not a log that we expand. Okay, well the derivative of its e is basically itself times the derivative of the exponent. Okay, if I want to clean it up, if you see it in a multiple choice, it would look something like this. All right, Moving right along. Again, if you ever want to freeze this, please freeze it. Now, I see ln, all right, on this one. Just look at it, see what you might want to do, okay? Maybe if I break it apart, ln e to the x plus e to the negative x, and then minus ln of 2. And I'll put a y on this. Okay, so if I do y prime, well, guess what? When I take the derivative of this part, what is that? Well, that's just a constant right there. So that's going to be 0. So really, I'm just doing the derivative of this part. 1 over e to the x plus e to the negative x. All right, times. Now, I have to multiply it by the derivative of this. Okay, well, since this is a plus, each of these are separate. The derivative of e to the x is e to the x. Derivative of this is e to the negative x times negative 1. All right, let me go clean it up. This is in the numerator, e to the x minus e to the negative x. And then in the denominator, e to the x plus e to the negative x. Now, realize let's see, so this can be our final answer right here on this one. Now, I want you to realize this is e to the x minus 1 over e to the x. You can actually simplify this further, because if I multiply everything through by e to the x, to get rid of these like fractions within a fraction, my final answer is going to be, think about when I multiply this, I add my exponents. So that's e to the 2x. All right, this just makes 1. All right, this makes, again, you're adding your exponents, e to the 2x, and then plus, and when I multiply these cancel, so that just makes 1. So this is another way to leave it. If they have it in multiple choice, they're going to leave it like this. Otherwise, I'm okay if you leave your answer like that. Now, what's going on here? If you recognize, you're going to have to do the product rule. I got two different functions right there. So f prime of x equals, all right, e to the 3, and actually, nope, I don't have to do that. Okay, it isn't product rule. Why is not it product rule? I'm wrong. Is there an x right here? No, this right here is actually just a constant. Okay, so here, when I go find the derivative, really, I'm just multiplying e to the 3 times the derivative of ln of x. So it's e to the 3rd over x. Now, you can use product rule. Just realize the derivative of e to the 3rd is just 0, okay, because that's a constant. Now, if it would have had x with it, it would have been something else. Okay, let's go look at this right here. Now, some of you are just going to roll with it, and you're going to say, okay, derivative of ln is 1 over e to the x, and now you times it by the derivative of e to the x. Well, that just gives me 1. But wait a minute, some of you are going to realize, well, the natural log of e to the x, remember, natural log and e, think of it as canceling themselves out, is just going to be x. And what's the derivative of x? 1. All right. Either way you do it, you still get the same answer. All right, here we go. Okay, what do we got here? Well, I don't have a natural log. I don't have a log. I do have this constant raised to an exponent. Okay, but then I have quotient right there. If you want to make this so it's this way, you're welcome to, and do product rule, but I think I'm just going to go with the quotient rule on this. Okay, so here we go. I do the bottom, low, times the derivative of the top, which is 3 to the 2t times ln of 3 times the derivative of 2t. All right, minus, okay, then I do 3 to the 2t, and then I times it by the derivative of t, which is just 1. All right, and then t squared. Now, one thing I recognize is, do you see how there's 3 to the 2t? You can actually factor that out, and you're going to be left with 2t ln of 3 minus 1 all over t squared. Nothing cancels out, but that's just another way to write it. Okay, otherwise you can leave your answer like this. You might want to put the 2 out in front though. All right, now here I have a log. Okay, so let's just recall how we do logs. All right, it's 1 over 2x, whatever's sitting here, 2x, the ln of that base right there, times the derivative of that, which is 2. When I go to clean it up, I get 1 over x ln of 10. All right, and lastly, last problem. If you can do it on your own, go do it on your own. If not, keep watching. If you said I need to expand this, you are correct. Log base 10 of x squared minus 1, okay, minus log base 10 of x. Now, some of you may decide to divide that in, and so you wouldn't expand the log. Either way is going to work. It's just our answers may look a little different in the end. Okay, so here we go. It's going to be 1 over, okay, we put the x squared minus 1, all right, the ln of 10, and then we times it by the derivative of this, all right, minus 1 over x ln of 10, and then you times it by the derivative of x, which is just 1. We can leave our answer like this and just put the 2x on top. You can get a common denominator either way. If you want to see the common denominator, I noticed both of them have ln of 10, so I don't need that. But this one would need an x, so I need to put it up top. This one would need an x squared minus 1. Okay, so this would make 2x squared. Okay, I'm going to distribute this negative through right here, so it's plus x squared, or actually minus x squared minus plus 1. Okay, because what I did was I distributed it here. There we go. Okay, the new denominators, this right here. And when I clean up, this is going to be x squared plus 1 over x squared minus 1, and ln of 10. And it can't do anything else because this is x plus 1, x minus 1. The top, the numerator, doesn't factor. All right, so be able to, if it's a multiple choice, you've got to be able to get it into a condensed form with most likely a common denominator. If it's not, you can do what I did in the black up here and just kind of leave it, and that's going to be fine if it's an open-ended question. All right, so make sure you memorize your logs, okay, or your derivatives for logs. If you ever see an ln or log, you may have to expand, and that's coming from pre-cal or math 3, wherever you started that out in. All right, and again, these are a little more difficult for me. All right, these are a little easier. You do use these more than you use this, but you need to have all of them memorized.